Okay, so let's start. We have ended the paper over here. Now we are going to start question number 3. Titanium is a transition element in period 4. It is commonly formed as TiO2 in minerals, that is titanium 4 oxide. Define transition element. Yes. Who can define transition element?
It is a D block element with a it
Okay.
is it is a D block element that can make one or more stable ion with uh, incomplete D subshell.
Good profile. D block element which can form one or more stable ion having an incomplete D subshell. Identify 2 typical properties of transition elements. So the 2 typical properties, one is the most important one that everybody is familiar with, that they have a variable oxidation states. They form colored compounds. Their compounds are colored. They behave as a catalyst. So these can be the properties which can be written over here. Further, they form complex ions as well. Okay. Now, part B. The TiO2 positive ion forms when TiO2 reacts with an excess of sulfuric acid. Okay. TiO2 positive ion can be reduced by zinc metal in acidic condition to form purple solution containing Ti3 positive. TiO2 positive is a colorless ion. Suggest why. Okay. So it means they are asking about why it is colorless. So if you look in the periodic table, yeah, here we have a titanium. Its atomic number is 22, right? So if its atomic number is 22, and if we look in TiO2 positive over here, which is indicating that basically the 2 positive is the net charge. Oxygen is -2 over here. So titanium must be +4, right? In TiO2, the oxidation state of if you look at the electronic configuration of a titanium having a 4 positive oxidation number, let's have a look. It means it have a 4 electrons lesser than the atom. Atom have a 22 electrons, so it must have a 18 electrons, right? So it is 1s2, 2s2, 2p6, 10 electrons, then 3s2, 12 electrons, and 3p6, 18 electrons, which is actually showing, it means that 4s is 0 and 3d is also 0, right? So there is no electron in uh, 4s and 3d. So if you recall, the color, uh, the principle, how the color these transition elements their compounds show the color, the reason behind is the splitting of the d orbitals. When the d orbitals got splitted and the electron from the lower d subshell, lower energy, jumps to the higher energy by absorbing the light. So but here, if as the d is empty, so there would be no this absorption of the light, and no electron can transition from the lower energy to the higher energy by absorbing the light, right? So that's why if light is not absorbed, the color is not shown, and that's why it is colorless. Is this understandable to everyone? So I can
Yes,
write
sir.
over here that in TiO2 positive, the oxidation number of titanium is 4 positive. So no electron in its d subshell, hence no light is absorbed from visible spectrum. So if it doesn't absorb any light, so it doesn't going to show any color. Is this clear to everyone? Give the electronic configuration of an isolated titanium 3 positive ion. So if it's a titanium 3 positive ion, so how many electrons it may have? The total electrons in titanium atom are 22. So it means it have a 19 electrons. So 1s2, 2s2, 2p6, we have a 10 electrons. Then 3s2, 12, then 3p6, 18 electrons, and then we have a 3d1, because first the electrons are removed from 4s, then the electrons are removed from 3d. So there must be one electron in 3d when the titanium have an oxidation number of 3 positive, right? Okay, now next part, write an ionic equation for the reduction of TiO2 positive by zinc metal in acidic condition. Okay, so if you see over here that they have given me the reactant that is a TiO2 positive, the other reactant is zinc metal, the acidic conditions is also in the reactant, and this one is the product. So I can write the equation over here that TiO2 positive is reacting with a zinc metal in an acidic medium, forming the product Ti3 positive. Okay. Beside Ti3 positive, we have a oxygen and hydrogen over there, so they are going to form H2O. And if you recall, we already worked on the oxidation state of titanium in TiO2 positive, which is positive 4, and here it's positive 3. So it means it gained one electron. If you look over here, it's zinc, which has oxidation number of 0. But normally what happens that when zinc, if titanium is undergoing reduction, it clearly indicates whatever the product zinc turns into is by a loss of electrons and normally zinc just lost two electrons and always form zinc 2 positive ion. So this one undergoes reduction. So the zinc would undergo oxidation, and zinc are losing two electrons, which means that there must be a gain of two electrons. So if I have to make a gain of two electrons, there must be two TiO2 positive ions and two Ti3 positive ions. We have a zinc over here. Now we have a two oxygens over here. So it means there must be two oxygen over here before water, which makes four hydrogens. So I would write four before H positive. Is this understandable to everyone?
Yes, sir.
If anybody have any doubt, kindly ask. Now, next part. Acidified titanium 3 positive reacts with oxygen dissolved in water as shown. Okay. The standard reduction potential of E naught of. Okay. Let me remind you, for this paper, that is actually year 2022 42, since it's the latest paper from the last year, you are not going to be given a data booklet. So this kind, if you got the equations like these, you have to make it in on your own as we did it right now. Otherwise, if there is a need of electrode potential, so there they would be given like this. You are provided the electrode potential over here, and beside this, the periodic table and the constants are given at the end, as you can see over here. See, for the NMR, yeah, it's an NMR spectrum. So you have the NMR table over here with the question, and here you have the constant values, all the constant values, and at the end you have a periodic table. Okay, so it clearly means, for example, if you are given with the equation and you are thinking about that, you need a E naught value, so you must know that if E naught value are needed, then it must be provided over there. If it's not there, so it means there is no need of E naught value. You can do it without that E naught values. Okay. So calculate the standard reduction potential E naught in V volt of TiO2 positive and Ti3 positive aqueous half cell. Show your working. Okay. So see this part. It is also from the latest edition from the syllabus. That is the relation between Gibbs free energy and the E naught value. See here you are provided with the Gibbs free energy, and here you are provided with the E naught of the half cell, and that is the reaction that is occurring in the half cell. So if you recall that relation is that change in Gibbs free energy is equals to negative n times Faraday times E naught cell. That is the relation. So we got the Gibbs free energy, that is minus 436 kilojoules. Okay, and here n
Sir,
is the number of moles. Yes,
sir, how do we know this expression?
you don't know this expression, Hamna?
No.
Why?
मुझे भी नहीं आती.
You have these notes, right? See at the end, everyone. Yes, Hamna, check and tell me whether you had this expression or not.
I'll check again.
But the thing is that it was actually this subtopic is added actually last year. So since when you do the questions, the past papers from 21 and backward, you are not going to find any question from this, but we did in our classes.
Right side. Found it.
Okay, so everyone else, if you didn't remember, so it means you didn't review the notes properly. Okay, so but you are not going to find in the previous years, but from 2022 onwards you are going to find this. Okay, so we are provided with the four 36. Okay, now the number of electrons here, I have a 4 electrons over here. Now yes, if we see in the net equation, here we have a 3 positive charge, and here we have a 4 positive charge, and the moles are 4. So it means in the net equation, the total number of electrons which are changing are 4, right? So the value of n would be 4. Faraday would be 96500 coulombs. And we don't know the E naught cell, right? That we have to find. So if I make the E naught cell subject, it would be minus 436 over minus 496,500. So anybody can tell me the answer?
1.13 into 10 to the power minus 3.
1.13 into
Into
10
10 to
raised to
the
the power minus 3. So
yes.
here it's in kilojoules, right? This is in kilojoules. And normally, if we got the value in volts that are normally, if you see over here, for example, that they are in 3 significant figures. So you have to convert it into joules, okay, to get the exact value of volts. So I think it would be then 1.13 volt. Yes. So I would putting down a point over here for this, that delta H must be in joules, not in kilojoules for this expression. Okay.
Sir, delta H या delta G?
Sorry. Yeah, it's delta G, not delta H. Yes, delta G would be in joules to get the value in volts. So I got the E naught cell that is in volt, and it's a positive, right?
Yes, sir.
So from this, what I can conclude, I have that this one is the one where the reduction is taking place, because we got this value positive. So then we use the E naught cell expression from the electrochemistry, that is E reduction minus E oxidation. And here E naught reduction is basically E naught of oxygen water minus E naught of titanium 3 positive and TiO2 positive. So it would be E naught cell is 1.13. E naught half cell of oxygen and water is 1.23, and it would be X. So the value of X would be
0.13.
1.23 minus 1.13. So what would be the value now?
0.1, sir.
0.1 volt. So the answer would be 0.1 volt. Is this clear to everyone?
Yes, sir.
Yes, if anybody have any doubt, kindly ask. Okay. Okay, just give me a minute, please. Sorry. Yes, is this clear to everyone?
Yes, sir.
Now, 3C2, when aqueous citrate ions, okay, are added to titanium 3 positive ions, the complex forms, okay. Explain in terms of d orbitals why titanium 3 positive is able to form complex ions. So basically, if you recall titanium 3 positive ions electronic configuration, it is only 3d1, which means that there is only one electron over here, and rest of the d orbitals are vacant or empty. Yes, Taha, good. So we can write that in titanium 3 positive ions, there are vacant d orbitals so it can form dative bond by accepting lone pair of electrons from ligand. Is this clear? So acidified this complex does not react with oxygen dissolved in water, unlike acidified titanium 3 positive. Suggest why this means for the value of the standard reduction potential of the falling half cell. So if you recall that the reaction of oxygen dissolved in water, we have a half equation over here, and its value is positive 1.23, and in the presence of this, titanium 3 positive is oxidized, so it means its value would be lower, but it is not reacting with oxygen, so it means it doesn't undergoing oxidation. So it means the value for this half equation, or the value for this E naught cell, would be actually greater than this value. That's why this reaction could not occur. Is this clear?
सर बिकॉज ये इलेक्ट्रॉन गेन कर रहे थे रिड्यूस हो रहे हैं तो उसका ही मतलब इसी वजह से हो गई एस की वैल्यू हायर.
This is by convention. We always write the equation in this manner, if you recall.
जी सर.
If you see over here, the complex that they have mentioned, what is the oxidation number of that one?
3 माइनस.
Which is over there here in the product side.
जी सर.
So it means when they are talking about the reaction with the oxygen, in the way when it undergo backward reaction, and for that backward reaction could only be occur if its E naught value is actually lower than 1.23, then the reaction would occur.
तो मतलब
If
सर
it's
वही
low,
रिएक्शन हो रही थी इसकी हमने इक्वेशन को फ्लिप कर दिया है.
no, the equation I didn't understand. Can you repeat?
सर हमने इक्वेशन को फ्लिप कर दिया है ना इसकी, इस कॉम्प्लेक्स की.
No, we didn't flip. Normally, the equation is written in this way only.
जी सर.
Okay. Normally, we write the equation where the reduction is the forward reaction and the oxidation is the backward reaction. And if its E naught value is lower than this, then it can undergo backward reaction and it turns into this one by reacting with the oxygen dissolved in water. But here they are saying that it does not react with oxygen dissolved in water. And then what they are saying, that what suggests what this means for the value of standard reduction potential of the following half cell. So it clearly indicates that the E naught of this half cell is actually greater than 1.23. That's why it does not reacting with dissolved oxygen in water. Is this clear, Taha?
यस सर समझ गया. थैंक यू.
Okay. Is it clear to everyone else as well? If anybody have any confusion, kindly ask. So, yes, can you repeat? I couldn't hear if someone was speaking.
सर आपको इसकी ई वैल्यू को कैसे पता है कि 1.23 से बड़ा है?
Oh, okay. 1.23 is the E naught value of this oxygen dissolved in water, right?
Yes sir.
Okay. The normal rule is that the one which having a greater value would undergo reduction, and the one which would having a lower value would undergo oxidation. Is this clear?
Yes sir.
So see what they are telling you in the first statement, that it does not react with oxygen dissolved in water. And here it's a 3 negative, and this ion is over here. Ahmed, can you unmute yourself, please? Ahmed K. Thank you. So 3 negative is over here. So it means it would undergo oxidation when it reacts with oxygen and turns into this one. And for this, its E naught value must be lower than 1.23. But here they have informed us that it does not reacting with the oxygen in water, which clearly indicates that its E naught value is actually greater than 1.23. From this, we can conclude this thing from this statement. Did you understand, Solia?
Yes sir.
Or is it, or there is still confusion?
Sir, I got it.
Okay. So we can write that the E naught half cell is greater than 1.23, so the reaction does not occur. Is this clear?
Yes, sir.
I think you must write this way. Okay. Now D part. Some reactions of TiO2 are shown in figure 3.1. The anion ACAC negative is a bidentate ligand. Okay. The titanium ions in TiF62 negative and have a coordination number of 6. Okay. So it means there are 6 dative bonds. 6 dative bonds in this complex and 6 dative bonds in this complex. What is mean by the coordination number? Okay. So if you remember, we can write it is the number of coordinate bonds formed by central metal ion or metal atom. Okay. Now, write an equation for the formation of TiF6 from TiO2. Okay. So, in TiO2, is reacting with HF, forming TiF6 2 negative. Okay. Here the oxidation number is 4 positive and 4 negative, which is 0. Here 6 negative and 4 positive gives me 2 negative. So the oxidation number is same for transition metal ion, titanium. So it means there is not a redox, just a substitution. So I would need 6 HF, and the hydrogen and oxygen are left, which means they are going to form water. And there is one more thing that I have to check. Okay. There is only one mole, and if you
सर साथ में वो भी नहीं रहेगा 2H पॉजिटिव इसके
yes, what that I'm going to write over here, because it's an acid, so some of the acid is actually dissociates as well, so we add 2H positive over here. Okay. Is this clear to everyone?
H2O के साथ भी तो 2 लगेगा ना?
Yeah, to balance the equation. Sorry, there are 2 oxygens over here, so I would put 2 over here to balance the oxygen. And when I balance the oxygen, I am left with the 4 hydrogen over here, and here we have a 6 hydrogens. That's why we need to put 2H positive over here.
Sir, can't we just simply write H3O plus 2H3O plus?
Yes, we can write H3O positive instead 2H positive and 2H2O beside these two. You can just write 2H3O positive as well. In either case, it is correct. Okay.
Okay, sir.
Okay. Now 3D3. State what is meant by the bidentate ligand. So it is a species which can form two dative bonds with the metal ion as it have two lone pair of electrons. Is this clear? Now, shows both optical and geometrical isomerism. Okay. Exist as a 3 stereoisomers. Okay. The structure of one stereoisomer is shown. Okay. I think we already did this kind of a question in the one of the previous classes. So if you look over here, the angle over here is 90 degree between these two ligands, which means it's a cis isomer, and a case where we have a two bidentate ligands and two monodentate ligand. The cis one show optical as well, and trans doesn't show optical. Cis show optical in that case, and trans doesn't show optical in that case. When the coordination number is 6, and we have our two bidentate ligands and two monodentate ligands, and that's how we got 3 stereoisomers, because cis have a optical isomer as well, which means it's mirror image, and trans doesn't have an optical isomer. Is this understandable? Okay. So in one case, I just have to draw its mirror image. So for its mirror image, let's have a look what I would do. If I would draw over here, I think it would be more understandable for you people. See, in front of chlorine, I write a chlorine. In front of chlorine, I would write a chlorine. Then this, and here we have this. So That's how you can draw a mirror image. Is this understandable to everyone?
Yes.
Okay. Now for the other one, I have to show the trans, and in trans, first I would make the bond in the same orientation as it have. Then what I would do, I would put both the chlorines over here at 180 degree, and then one bidentate ligand over here and the other bidentate ligand over here, and that is the trans isomer. Is this clear? Okay.
सर जो हमने ब्रैकेट्स बनाई है इसकी साइड पे ये बनाना जरूरी है
Yes.
और अगर ना बनाए तो मार्क्स कट जाएंगे
Into this one. Yes, there is a possibility because see, they have shown you the brackets outside the complex.
थैंक यू
So you should make the brackets over here.
सर ब्लॉक
They
बनाना
show you.
सर ब्लॉक
So
बनाना
you
तब जरूरी
must
नहीं
draw the yes.
सर ब्लॉक बनाना तब जरूरी नहीं था जब कहते कॉम्प्लेक्स कोई चार्ज हो
I couldn't able to hear you properly, Rafael.
सर ये कहते हैं
Yes, at that moment it is mandatory that you have to draw the brackets when there is a charge over there, but I am referring to the structure that is provided by the examiner. Examiner is showing you the brackets over here, so you must draw the brackets. Okay.
ओके सर
The AC negative anion is symmetrical. Reduce which, if any, of the stereoisomer 1, 2, and 3 are polar. Explain your answer. Yes. Can anybody identify which one is polar?
सर the cis isomer and the optical isomer will be polar the trans isomer won't be
Why?
because in the trans isomer there are no partial charges
In trans, it will be cancelled out.
Yes, in trans, the partial charges, the dipoles are cancelled out because both the same ligands are exactly opposite to each other. So the stereoisomer 2 are uh, the one which are polar. So isomer 1 is polar as the dipoles cannot cancel out. Is this clear to everyone?
सर 2 भी तो होगा
yes sir 2 भी तो होगा
Yes, both are isomer 1 and isomer 2. Sorry, I have to mention that as well. Isomer 1 and isomer 2.
सर
Yes.
सर अगर मैंने स्टीरियो आइसोमर 2 वाली जगह पे मैंने ट्रांस बनाया और स्टीरियो आइसोमर 3 वाली जगह पे मैंने सिस बनाया तो
It
ऑप्टिकल
doesn't
बनाया
matter. It doesn't matter. Then in the next part 5, you have to mention that it's just your stereo isomer 1 and isomer 3 are the polar. Okay.
Okay, sir.
Okay. Now we're going to start with question number 4. Compounds F and J are shown in figure 4.1. Okay. They both contains the arene functional group. Identify the other functional groups in the next. Yes.
Carboxylic
Beside
acid.
carboxylic acid, what else?
Amine.
Amine.
Amine. Okay. So in F we have this one, a carboxylic acid, and here we have amine. This is amine, and remember, if you include this whole, then it is considered as phenylamine. So you can write either one.
Sir, yeah, right.
अरे J अलग molecule की
Oh, sorry, I overlooked. So carboxylic acid. Okay, that is amine. And if I consider the part which is in the green, then you may write phenylamine. So either you can write amine or you can write phenylamine, anyone, because both are amines. Okay, now in J, what functional groups are there?
ester
And alcohol.
Ester, and not alcohol. That goes wrong.
phenol.
It's
Phenol.
phenol. Yeah, because we do not consider phenol and alcohol exactly the same. That is phenol, and that is ester. Yes, is this understandable?
Sir, can we write alkane for J?
Sorry,
Can we write alkenes for J?
alkene.
Alkanes.
Are you saying alkene?
No, alkane. Cyclohexane.
It's a psych. But actually the alkanes are not a functional group in actual, because alkane or alkyl is the thing that is actually present with the everything. So we do not consider them as a functional group. Okay.
Right.
Normally, when we talk about alkanes, we say there is no functional group in alkanes. Okay.
Okay.
Okay. Now in part 2, state the number of chiral centers in a molecule of F and in a molecule of J. Okay. So first find the chiral centers in molecule F. Yes, how many chiral centers are there?
There are none.
There are none. And how many chiral centers are over here?
Two or three, sir. Two, sorry.
2.
2.
Sir, दो है.
Okay. Can anyone suggest any other number except the 2?
It will be 3. One
This
more is
one
on the benzene ring.
and this
Please,
one.
sir.
3. Halima, where is the third one? Sara, where is the third one? Halima, where is the third one?
वैसे वो मैं गलत काउंट कर लिया था, एंड वाला मैंने किया था।
Okay, there are only two. The two which I place with the marked with the red dots, these are the two which are the chiral centers. There is no other chiral center in the whole molecule of J. Okay, so here we have a 0 and here we have a two chiral centers. Okay, now B part. A student proposes a multi-step synthesis of F from benzene as shown in table 4.1. Complete table 4.1 by providing relevant details of the reagents and conditions for step 1 and step 4 and the structure of the product D. Okay. I think for step 1, anybody and everyone can do figure out the reagent and the condition. Yes. What we are getting, we are
Anhydrous
getting a
AlCl3.
methyl group substituted for
Sir, CH3Cl plus AlCl3 catalyst.
yes,
heating.
and the reagent
Sir, CH3
methyl benzene. So there is
Halogenoalkane.
no need of heating over here. Yeah, here there is no need of heating. So CH3Cl and AlCl3. Then
why no heating is required?
there is no need of heating a benzene, but when we have a halogenoalkane bonded to a benzene, then we heat it.
Okay.
Okay. So here, okay, for this, I have shared you the reaction page. If you see over here, you can take the help from these. These are the reactions of A2 arene reactions containing the benzene ring. Okay. So if you see over here, we are using a concentrated nitric acid and group is already bonded. So if the methyl group is already bonded, it means that with respect to methyl group, the next substitution occur on
Second.
2, 4, and 6 position. But as we see our product, these two are 1, 2, 3, and 4th. So I would place a nitro group over here. Okay. Now, in step 4, this NO2 is converting into NH2, which is a reduction. And for that reduction, there, for this reduction, there is a very specific reagents that we use are tin
and concentrate
and concentrated HCl and heat.
सर 3 में D को फिर से नहीं बनाना होगा.
No, see here the position of D over here and here that is in the center. So there is no need to make D again. Okay.
Right.
Okay. In a second multi-step synthesis, the student changes the order in which the reagents and conditions are used. The reaction scheme is shown in figure 4.2. G is the major product of the synthesis. Okay. C. Okay, that's good. See, now we have a carboxylic acid bonded to it first, and we are using concentrated nitric acid and concentrated sulfuric acid. So if you look over here, when we have a carboxylic acid bonded to it, then the next substitution would occur at these position instead of these positions, right? So it means that they are asking the structure of the G over here. So in G, that the nitro group is now present at the third position from that carboxylic acid. Is this understandable to everyone?
Sir, can I make it at 5? Is it fine?
Yeah, it doesn't matter. If I make it over here, then it is still 3.
Right.
It's not 5. So because the numbering starts then this way.
All right.
Okay. Okay. Explain why G is the major product of the synthesis rather than E. Okay. So it's simpler that COOH group is bonded to benzene. This COOH group is electron withdrawing hence it directs next substitution at 3, 5 positions. Is this understandable to everyone?
Yes, sir.
Yes, if anybody have any doubt, kindly ask. Okay. Now, C part. J reacts under suitable conditions with NaOH. Okay. After acidification of the reaction mixture, compound K and L are formed. Okay. Give the molecular formula of L. So can anybody figure it out what is L? If you see from the
ब्रेक हो रहा है तो जो साइक्लिक एल्केन है वो और उसके साथ OH लगते हैं जहाँ पे O है.
very good, Rida. So we can easily figure it out if you see over here that this is broken down from here and here we got an H and this whole thing they are calling it K. Okay, 1 minute, sorry. Actually the ester, this bond is not broken. Actually from ester this bond is broken, which is a carbon double bond O and a oxygen. So if this bond is broken, so we got an OH over here and this thing becomes K. So we are left with this whole thing and this O is bonded to H and that is going to be your L. Is this understandable to everyone?
है यहाँ पे जो NaOH है उसके साथ
Yes.
OH तो उसके साथ कार्बोक्सिलिक एसिड के साथ लग जाएगा. ऐसे नहीं होगा कि HCl का जो Cl है वो O के साथ लगे.
Cl is a spectator ion.
सही है सर.
And normally when we do the acidic hydrolysis, we use sulfuric acid or a hydrochloric acid. So it's a spectator ion. So if you see, you have to work on the molecular formula of this one. Here I have a CH2 here I have a CH2, here I have a only have a CH3 and CH3. So if you write the formula, how many carbons we have? 6, 7, 8, 9. There are 9 carbons. How many hydrogens we have? 3 plus 3, 6, 9, 10, 11, 14, 15, 16, 17, and 18. Right? 18 hydrogens, and we are left with the one oxygen. So C9H18O. Is this clear?
सर ये CH3 कैसे हुआ लेफ्ट साइड पे?
Where?
On the left side.
Okay,
in
it's
the
CH2. Yeah, it's CH2. Let me count again. Sorry. So this is CH3. So 3 plus 3, 6, 6 plus 3, 9, 9 plus 2, 11, 11 plus 2, 13, 14, 15, 16, 17. Okay, I left one thing. Sorry. I overlooked. There is a CH over here as well. So that's why 18. Okay. Luckily, I got the correct formula.
Sir, ये जो
I
phenol
missed this. It's not phenol. It's an which one you are talking about? The K or the L?
L में इसमें salt नहीं बन रहा क्योंकि सोडियम के साथ सोडियम हाइड्रोक्साइड के
Yes.
साथ रिएक्ट कर रहा है.
Okay. Okay. With the reaction with sodium hydroxide, you are right. Actually, this is not going to be a salt. This is going to be a sorry. This is going to be a salt. But when we added HCl, the Na is substituted by the H and it transformed into acid instead of being salt.
Right, तो सिर्फ अगर सोडियम हाइड्रोक्साइड होता तो फिर salt बनता.
Or and if there is no HCl over here and there is sodium hydroxide, so there would be no H over here. Instead, we have a this thing. But then when
Okay,
we
sir.
added the HCl, that salt turns into a carboxylic acid. Is this clear to everyone?
Sir, in the molecular formula, can we write C9H17OH?
Yeah, you can write that way as well, but the most appropriate way of molecular formula is the way in which the number of atoms of each element represented once only.
Okay, sir.
State two types of reaction that occur when J reacts with NaOH. Okay.
Yep.
So when J reacts with NaOH, first is the hydrolysis. And due to that hydrolysis, this compound is broken down into two, and we got a carboxylic acid and an alcohol. And that carboxylic acid form actually reacts with this NaOH to form that salt that I have mentioned over here. So then the next reaction that occur is acid-base reaction. Is this clear to everyone?
yes sir.
Okay, just wait for a minute, please.